Today, we will learn how to encrypt using RSA encryption scheme. As we know, this RSA is public key encryption. So, there will be two keys. The one is private key and another is public key. In this video, we will learn only the encryption and not the signature. So we will learn only encryption, not signature. In the pycryptodome library, we have these two things. The one is PKCS #1 OAEP RSA, and we have another thing which is the simple RSA. Now if you note, these are in different packages. The RSA is in the crypto public key package, and the OAEP, this one, it is in the cipher package from crypto.cipher import PKCS1 OAEP. So these two are a little bit different thing. The RSA is used to generate and store the keys. We can export, store, generate, construct keys from this package, whereas this one is used to encrypt the real data. Now we will see how we can use these two things together. So first of all, we import from crypto.cipher, we import PKCS1 OAEP. Also, we import from crypto.public key, we import the RSA to generate the keys and to construct them. Now, let us go to the documentation. In the documentation, we see that to create the key, there is this command, my key equal to rsa.generate 3072. So it is the size of the modulus. Now we generate this key. We write my key equal to RSA dot, it is generate. So we generate a key of size 3072 bits. Now this will generate the key. Now we generate our cipher. So our cipher is pkcs.new, and we are using our key my key, and we can see this in the documentation also. When we go to the OAEP, so what they do, they will construct the cipher using the key. They have imported the key from the RSA, but we will talk about it later. So basically they have constructed the cipher from here. Now we encrypt some of our data. So this is the message. Now we generate a message. We write message equal to P, and we write here our usual message, we all will not attend the meeting. So we have written this message. Now we need to encrypt it. So we write ciphertext equal to cipher dot encrypt, and what we want to encrypt, our this message. Now we print our ciphertext and see if the encryption is being done in a proper way or not. we see that it has encrypted our data and given us this bytes of data. So as RSA is public key encryption, so the size of the encrypted text can be different from the one which we have given. Now we need to decrypt it. So we write decrypted text equal to cipher dot decrypt and ciphertext, and let's see if it can decrypt it, and we print the decrypted text also. Print decrypted text. So we click on run and we see it has given us the decrypted text also. We will not attend the meeting. So in this way you can encrypt and decrypt using the RSA. But there is a catch now. The catch is that as the RSA is a public key encryption scheme, there are two keys. One is public and one is private. So the receiver can make his public key open to anyone and can put his secret key into some safe place. So now we will see how does that happen. So we have generated our key, my key, from here. Now what we will do, we will give this key to someone else. So we will export this key. File equal to open. We will write some name here, public key, and we will then define the writing, and we will write here the public key dot pem. This is the format for the keys, or for a better representation I will use txt so that I can show you the key. Now this file is open. Now what we do, we write file dot write my key dot public key dot export key. So this will export the public key to this. I think it is a function. Okay, so then we will file dot close. Now we will see if it is working. It has given the output, so it means everything has been done fine. So here is our public key dot text. So this is the public key which anyone can use to send message to the receiver. Now we need to safeguard our private key from here. How we will do that? So we go to our program and we go to the pycryptodome library and we see that how to export the private key. So we will just copy this phrase because there are various parameters which for now we don't need to know. What we need to know is that there is some password, so that only the one who has the access to the private key can open this. So we will define this password and we will export this data. So what we do, we just copy this data, this command, and I will use it here to show you that everything is working fine. So we need the private key now. So I will use the private key in the decryption purpose. So I will just paste it here. I am just correcting all the spaces so that it is a valid Python program. Okay, and there is some space error here also. So this is our data, and this has been exported. Okay, so we are doing export, so I will put this thing into the above one. So we will write file dot open private key dot pem. Now this is a format for the key, and we will write wb, and we will now paste this data, and we will write this data to this file, and now we will close it. So this has exported the private key also, and we need the password. So we use password pwd equal to password. So this will be the password for our secret key, and here is the cipher which we created, new cipher. Okay, so till now we have just exported and we haven't imported anything. Now my key, now we will import the public key. So my key equal to, and we will go to this library, how we import the key. So in the import you can see that they're using the .pem format, so we will use this same format. We will export the public key in the PEM, and now we will open this file equal to open public key, let's say public key dot pem, and this is in the format RP. Let's see if we are doing right. Open public key dot pem. Okay, so we are using it to read. Now my key is equal to file and dot read, but this is going to be in the RSA. So they are using RSA dot import key. So we use RSA dot import key and file dot read. So it will import the key from here. This will import the public key only. So now we create the cipher using this public key, and we will encrypt it. Now let's see if it is working fine. So now there is some error. So file open private key.pem and wb. Okay, so we have used this dot, that's why there is a problem. Okay, all right, so there is one more problem. We have, this is exported the private key, then here it is the public key. Now we are going to use it for the encryption only, and let's see how to import the public key and cipher encrypt message. Okay, now we need to import the private key also. So we write here file dot close, and after the encryption we will define the my key as like this, and Now we will define the cipher equal to pkcs dot new and my key. And let us see what name we have given. We have given the name private key.pm. So we will use the same name, private key.pem, and now we will run it. So still there is some problem. Okay, so we haven't put the passphrase. So how do we import the password file? So this is given in the pycryptodome library, and we will look into the RSA package. So this is the exporting of the key, and to import RSA.import key data, and there is comma with the password. So import key dot read, and now we use the password. So we'll use the same password. Now we will run it again, and you see that it has now worked fine. So we saw how to encrypt our data using the RSA and how to decrypt our data using the same RSA. We also exported our key and we imported our key. Now the private key was stored using the password so that only the recipient can access it, whereas the public key was just stored like a simple text, and it can be given to any of the sender. I hope this tutorial has given you enough knowledge of encrypting using the RSA scheme.